Okay, this is Mr. Peterson, and we're starting the second page of the 1.5 notes in Algebra 2. So we have to isolate, if you looked at the previous video like you should have, we should isolate this absolute value. I'll start by subtracting 30. We get rid of the addition first. And then I'll simplify. Then to get rid of the times 3, you have to divide by 3. You can't multiply over the parentheses. And that would be because these aren't parentheses. So that cancels. And we got the absolute value of 2x is equal to negative 6. Okay, so we'll eventually figure out that this is going to be impossible. But for now, we're going to split it up, and you make 2 copies of the original, but you leave the bars off this time. Put the word or in the middle. That's the one you use. And the second copy, in order to get its answer, you have to multiply by negative 1. And let me show you what that would be like. If you had absolute value of 2x and then equals whatever over here, okay? And you're multiplying by negative 1 in there. Well, that negative 1 has an absolute value of positive 1. So really, in disguise, you're multiplying by 1 up on that line above where we're at here. Well, this first one here gives us, if we divide by 2 here, we get x equals negative 3. In a minute, we're going to check this out and see if it works. This one, if you multiply negative 1, you get negative 2x equals negative 6. And divide by negative 2 here. And you get, I'm running out of room here, so I'm going to have to come up here. X equals 3. So now we're going to try these. One of the steps you had to do was to check them. So we'll try this negative 3 right there. Actually, let me do it up here. That's where it has to be. So 2 times negative 3 would be negative 6. And then we have the absolute value, that's positive 6. 6 times 3 is 18. 18 plus 30 is 48. And 48 does not equal 12. So we have our first example here of an extraneous answer. So you gently cross it out. You don't want to obliterate it. I don't know if I said that right. Anyway, that one's extraneous, and you should both cross it out, write it down, and then you should write extraneous next to it. Okay, now let's try 3. If you take 3 and you put it in for the x, 2 times 3 is 6. Absolute value of 6 is still 6. 6 times 3 is 18. 18 plus 30 is 48, and it still doesn't work. So this one's also extraneous. And since both of the answers were false, this one has no solution. Now, if you were really paying attention, you might have noticed something earlier that would indicate that there's no solution. We got down to this point here where the absolute value is by itself, and we would know at that point that that side would have to be a positive number, and this side is a negative number, and that's impossible. So if you get down to this point and you realize that that's the case, you can say positive does not equal negative, and just simply write the answer, no solution. So you can take a shortcut. Okay, it would be tempting to take this negative sign here and distribute, but you're not allowed to with absolute value bars. So we have to subtract 10 off the other side. Which takes us to the opposite of the absolute value of 2x minus 6 is negative 2. Now this one here, to get rid of the negative in front, you divide by the negative 1 that's implied there. And that'll cancel this off. And at this point, we have the absolute value isolated. Make 2 copies of it. Separated by OR. And the second version of it here, you multiply this left-hand side by -1. Okay, so going down the right side, we'll add 6 to both sides and divide by 2. So we'll check this out later. We're not sure it works. Might be extraneous. Okay, I'm going to multiply by -1. I distribute the -1. At this point, we have a parenthesis, so I'm allowed to do that. Subtract 6 on both sides. Divide by -2 on both sides. So now I'm going to check these answers out. I'll start with the 4 and put it in right there. 2 times 4 is 8. 8 minus 6 is 2. The absolute value of 2 is 2, and 10 minus 2 does give 8. So that's a legitimate answer. We'll put a little check mark next to it. Okay, the number 2 is the next one we want to put in. So we're going to take 2 and put it in right there. 2 times 2 is 4. 4 minus 6 is -2. The absolute value of that -2 would be +2, and 10 minus 2 would be 8. So we have 2 answers there, 4 or 2. Okay, so the next example illustrates how to handle equations with an expression on the right-hand side. And one of the advantages of this new way that I'm showing you is that you really don't do anything different. That's a huge advantage, because I used to have to explain that in one case you do one thing, in another case you do another. So since we have the absolute value isolated by itself already, we're ready to split this up. Make 2 copies of it, but leave the bars off this time. Multiply this side by -1 on this one to get the alternate answer. And we'll put OR in the middle. Okay, if I take the x to the left and the -8 to the right, this would be 2x minus x equals 2 plus 8. So x equals 10. While we're thinking about it, we're going to plug a 10 in. You need to put it in the x there and the x there. The right-hand side is going to be 12. 10 plus 2 is 12. This side is 2 times 10 is 20. 20 minus 8 is 12. The absolute value of 12 is also 12. We're dealing with a legitimate answer there. So I'll go ahead and validate that one with a little check mark. Okay, -2x plus 8 I distributed. And you're allowed to at this point because it's a parentheses. I'm going to take the x to the left and the 8 to the right. So it's going to be -2x minus x, and then that's going to be 2 minus 8. This gives -3x equals -6. So apparently if you divide by 3 on both sides, x has to be 2. Let's check this one out. 2 there would give 4 on the right. 2 here would also, if you take it through all the work, give 4 on the left. Think it through. 2 times 2 is 4, minus 8 is -4. The absolute value of -4 is also 4. So we have 2 legitimate answers there. Okay, so the next one here, I've got a little work to do. I've got to isolate the absolute value first. And that's going to give x plus 8 is 2x. And then when you add 2 to both sides here, you get -6 over here. So now I'm going to make 2 copies of that. Notice that I leave the bars off. The second copy gets modified. It's like putting a -1 inside the absolute values when you do that. And the absolute value of -1 is just +1. So in the context of these absolute value problems, that's actually like multiplying by 1. So I'm going to take x and bring the -2x over to join it. And on the other side, I'll stay with negative 6 and subtract 8 from the other side. And dividing by negative 1 here gives 14. So we'll try that 14 in a minute in the problem. Here we're going to distribute the negative sign. Bring the x's over to the left. This gives negative 3x equals 2. So x equals negative 2/3. Okay, now it's time to check these for extraneous answers. So 14 is going to go in here and here. On the left, you have 14 plus 8 is 22. The absolute value of 22 is 22. Minus 2 would be 20. So the left side is 20. Now the right side, and you put a 14 in there, is 20. 2 times 14 is 28. 28 minus 8, and that is also 20. So this checks. You may use a calculator if it helps you with this. Okay, so let me explain. Well, if you take this negative 2/3 and you plug it in for the value of x, and give me a second to do this on my calculator here. Negative 2/3 plus 8 is 7 1/3. The absolute value of 7 1/3 is 7 1/3, and then minus 2 gives 5 1/3 on this side over here. So then if I take 2 times negative 2/3, I'm doing the other side now, minus 8, I get a different value of negative 9.9 1/3. So this one here is extraneous. I'll cross it out gently and put EXTR. And now we're ready for the next problem. Okay, if you get a positive number equal to a negative number, I've already mentioned this. Your problem is impossible and you have no solution. So here's another example to remind you of that. I'll divide both sides by negative 2 to get the absolute value by itself. Now if I pause there, because of those bars, that will be a positive number, but on the other side I get a negative number, and a positive number cannot equal a negative number, so you just write no solution. Now you need to write this in here so I know why you thought it was no solution. Okay, so here's where the payoff comes. Normally when I get to these inequalities that we're going to do here, you'd have to learn a completely different way of doing it. But here we're going to use the OR split again. Notice that the first round, when it says greater than, is looks like a copy of the original, but the bars are missing. Well, we do it again over here. We'll make a copy of the original, but leave the bars off. And we give it the -1 treatment just like before. All right, so if you were to solve this, you'd have both answers. So let me show you an example of this here. X is greater than 6 would be your first part of your answer. So let me get a scale going here. We're going to be on that side of 6. And if you do the other one, divide both sides by -1, which flips the sign, you find out that the other answers are to the left of -6. The answers are in what looks like kind of a split graph where part of it goes to the left and part of it goes to the right. All right, so greater than, once you have the absolute value isolated, if you got a greater than there, you use the OR split. And I'm going to remind you of this. I'm going to misspell greater than. It's supposed to be ER. I'm going to make it OR than, like that. Greater than. And the OR split. Later, we're going to have one that splits using the keyword and. Okay, that does it for page 2 of the notes.